Hello, we are going to be talking about variable scope in this video. It's a topic we touched upon earlier, but we are going to just go into a little more depth this time. So let me present this and let's get started. Okay, so just as a quick review, what is a local variable? So we saw last time that a local variable is just a name that appears on the left-hand side of an assignment operator inside a function. So when that happens, what it does is it creates a local variable. And local variable means that variable is only visible inside the function. Okay, so you can read and write to it inside the function, but once outside the function, that variable no longer exists. Yep. So we say the scope of the variable is local to that function. So that's what a local variable is. And what is a global variable? Well, a global variable is basically a variable name, or a name that appears on the left-hand side of an assignment operator that's outside of functions. Okay, and a global variable is visible pretty much everywhere, and it's, I mean, by that that implies it's visible inside the function as well, right? So we'll create a global variable called message here outside the function. You can use that same variable inside the function. Okay. And now we did conclude that global variable is bad for passing information to a function, right? If you remember the restaurant analogy, and hopefully that makes sense. Okay, so if we want to pass information to a function, we do not use global variable. Instead, we use what we talk about function parameters. And in order to return information from a function, we use the return keyword. Okay, now we didn't quite talk about if we can use a global variable to return information from a function. And that's what we're going to talk about today to help us understand what these scope, global scope and local scope mean. And then we will also talk about assuming we can use global variable to return information from a function. Should we do it? Okay, so let's start by consider this example that we wrote last time and that I recreated here. We wrote the area of a circle is the pi r square. Okay, and when after we calculate it, we return it. We call the function here. We capture the return value in the variable and we call it, right? So if we run this should print out the area of a circle of radius 10, 314. Okay, so what if we, instead of using return, can we get this function to modify a global variable? And in that way, it kind of quote unquote returns that that the area of a circle for that radius. So let me write out what I mean by that. So we can create a global variable called area, right? So area should be visible inside the function. And so we should be able to modify that variable area. And in that case, we are, we're setting a global variable, and then we can try to print it out and see if it get properly modified. So do you think that works? Let's run it. We run it and the global variable remains 0. So it was not modified by the function. Okay, so that was the idea and it did not appear to work. So why? Let's do a little poking around. Like when things doesn't work, let's print out things, right? So let's print out, okay, we're inside function and then the area is equal to, so did we successfully modify it? Format area, and then outside, obviously we print it out, but we want to say, we're at a global scope. Global and area equals to that. Okay, so we print out area inside a function and we print out area outside of a function at the global scope. And let's see what happens. Well, so inside a function area, we have indeed set it to 314. But when it comes to the outside, we say, whoops, I forgot to say that. Outside the function at the global scope, the variable area remains at 0. How did that happen? Now, that happens because of something that we have just said, that when a variable name appears on the left-hand side of an assignment operator, I forgot to say, inside a function, okay? So when we're inside a function and the name of a variable appear on the left-hand side of an assignment operator, that creates a local variable. And that local variable is only visible inside the function. So this is what we said in this review, in this slide. So you can go back and read it. That's why this is such a long sentence and such an important slide, because we already said that. And so again, very important when we have a variable name, when we have a name that appears on the left-hand side of the assignment operator inside a function, it always creates a local variable. Okay, so we have a local variable called area, and we have a global variable called area. Okay, so but those two variables, even though they are both called area, they are different variables. One is local, one is global. So when we assign 314 to this area, it assigns it to the local variable area. And the global variable area, that was not changed. So that's why when this function is done, we come to print the area. This is the global variable area, and global variable area remains at 0. Okay, so is there any hope of getting this to work? Well, there is. So let me fix this first. That area equal to, okay, so we're back to area is still 0. Okay, how do we make this area refer to the global variable area rather than a local variable area? Well, we can do it, and as a matter of fact, you can just say global area. Okay, so if you use the keyword global followed by a name, you're essentially declaring that that name is referring to a global name. And in this case, that's the global area, global variable area. Okay, so and you can actually kind of see that when I click on the area here now, it highlighted all the names that this is referring to. So it's referring to this area, it's referring to this area, and it's referring to this area. So now all the areas is referring to the same global variable. Whereas before, if I don't have this line, you click on this area here, it highlighted the other area because both of these are referring to the global variable area. However, it does not highlight this local variable area here. Okay, so I say global area, and then if I run this now, and that works because now we are assigning 314 to the global variable area. Okay, so yes, there's a way to do it, but as soon as I show you the way to do it, I'm going to tell you this, that using a global variable for this particular use case is a really bad idea. Okay, so and the reason for that, if we want to use our restaurant analogy again, is that this would be like having a single physical plate for the entire restaurant, that when the kitchen want to return or want to serve a cooked meal to a customer, the kitchen has to put the meal into this single physical plate and serve that to a customer. So now imagine you have to serve 100 customers with this one physical plate. I mean, as we said before, I hope you can imagine this, that it's totally chaotic, it's very inefficient, and bad things, wrong things are pretty much guaranteed to happen. That some of the customer will probably get the wrong food or get no food at all. This is just a pretty messy situation. So even though it is possible, do not ever modify a global variable as a mean to pass information back from a function, ever. Just don't ever do it. And as we said before, don't use it to pass information to a function. And now we're saying don't use global variables to pass information from a function. Okay? Now, so is global variable ever any good for anything? Well, they do have their place. So the one really good use case for global variable is symbolic constants, such as the max principle that we use in our previous assignment. And the reason for that is, first, symbolic constants, they are read-only. Okay, so when they're inside the function, they will only ever be used on the right-hand side. They are only ever going to be read from. Okay, you should never write to a global constant. That's why they're called constants, right? So because they're read-only, you can never use them for passing any information back. You would never modify them from within a function or from anywhere, really. So they're fine in that sense. And also, there may be a lot of them, right? In our previous assignment, I think we defined 5 or 6 symbolic constants, and there could be many more of them depending on the size of your project. So it's very cumbersome if you have to pass all of them to a function by function parameters. Probably going to have a long list of parameters for a function. So it's not good. We don't want to have to do that. So in that case, it's okay for a function to access these symbolic constants that are global variables. Okay, and so now in terms of the actual code that we are writing, we've been writing and we're still writing up to this point, that we're still using lots of we're still writing most of our code at the global scope. And again, the global scope basically just means any code that is not inside functions. So any variables we create by the code at the global scope, they are global variables. That's just the code that we've been writing. But over time, we're going to move towards the goal of having fewer and fewer global variables. So we will, it's very soon, we're going to be moving the majority of most of our work into functions. So we will have fewer and fewer global variables. Okay, so as a summary, you use global variables, but only for constants and until we move our code into functions, most of our code into functions, and use local variables if inside a function you want to hold any sort of information, right? And most information that you need inside a function should really only be visible inside the function anyway. Now, if you want to pass any information to functions, like we showed last time, use parameters. And remember, parameters are really pretty much like local variables, except that their values can be set up by the callers. So use parameters to pass information to functions. And when you want to return information from functions, use the return keyword. Okay, so this way we encapsulate information inside of inside functions. So and remember, encapsulation is very important, and especially as our project become more and more complex, it's good to keep local information local. Okay, I think that's the end of this video.